Oh yeah, we made it to the last question. Here we go, number 7. All right, we got a movie theater. It's offering a special summer pass. Pass holders pay $8 per movie for the first 5 movies. Before we go on any further, let me just tell you: don't think about this as a math problem. Just graph it. You know how much to pay for a movie when you go to watch a movie and you look at the price. You can calculate how much you pay for 1 movie, 2 movies, 3 movies, right? So think about that real life application on here. This isn't just some problem on paper. I know for sure you could do this in your own life, and I know you can do it here on this question. So read the thing a couple times. It's best to read a word problem like 3 times before you try to answer it. We got the summer pass. Pass holders pay $8 per movie. Here, look at this part right here. $8 per movie. So $8 per movie for the first 5 movies. So you can go watch 5 movies and they're going to cost $8 each. And the cool thing about this summer pass is you can watch additional movies for free up to a maximum of 15. So if you pay for those first 5 movies, guess what? You get to go watch 10 more for free. This sounds like a great deal. I would definitely be interested in a summer pass like this. So the function C gives the cost in dollars for a pass holder to watch N movies. So the N is the number of movies they're going to watch. So here's our input. We plug in how many movies we watch, and our output, we find out what's it's going to cost. Now, this question, a lot of people see this where it says piecewise here, and all of a sudden they start doing one of these numbers, right? Oh, it must be something like this, right? Here's it's got to be like this, right? Don't do that. Don't jump to that conclusion, okay? First, I recommend go and try to graph this thing right away. Don't be intimidated by this problem. You know how to pay for a movie. How much is it going to be for that first movie? So it says $8 per movie. So if you watch 1 movie, guess how much you're going to pay? $8. Piece of cake. I'm going to put a point right there. You watch 2 movies, it's going to be 2 times 8, $16. Let's start plotting them. So the 1 movie is $8. You go watch a second movie. Now you've paid $16 in total. You go watch this third movie. You paid $24. And you know why it keeps accumulating here? Look, it says total cost. Not just the cost of each movie. We're talking gives the total cost. So what is it? 4 times 8 is 32. We got a nice continuous slope here. It's going up 2 squares over 1, up 2 over 1. And that last movie that you're going to pay for, 5, that 5th movie, 5 times 8, you've spent $40 so far, and you've seen 5 movies. All right, you paid $8 for each of those first 5 movies. Well, now here's the interesting part of the graph. We're gonna get to see 10 movies for free, okay? And sometimes on this problem, I've seen people that want to graph it down here. They're like, well, these movies are free, right? So shouldn't it be down here? But you know what it is? What's the problem is we're graphing the total cost here. So we already paid $40 to watch those first 5 movies. So you can watch 10 more, up to 15. But guess what? You already paid the $40. So you're up here. Your line's going to be up here. So let's draw a nice line over here. Technically, if we think about the fact that the inputs are whole movies, I guess, from here to here, since you're not paying anything, you could just show up and watch half a movie. You wouldn't care. You could go in there and just watch 20 minutes of a movie if you got some free time to kill. It's going to be free. So I guess it could make sense that we'd have a straight, continuous line over here. But show me something like this on your graph. If you put the individual points, that would be fine too. You don't necessarily need to draw this solid line. But there it is. Remember, plot the points, find out how much does this cost. Think about it in real life. If you go to the store, I'm sure you can figure out how much you're going to pay for a candy bar and a soda. You can figure out how to graph these points on here. Look at your axes. Number of movies is down here. Cost is up here. Plot your points. I'm going to go back to part A here at the end. Let's get rid of this domain and range business, right? We remember domain goes left and right. Okay, let's write that down here. Domain is all the inputs that make sense for this function. What could we plug in that would make sense for the domain? And you know what we got here? We've got number of movies for domain. And I was talking about up here, you could go watch half a movie, a third of a movie, a fourth of a movie. But really in real life, definitely as far as this part goes, you're not going to be able to go to the register and say, hey, I got $1. Can I just watch like 5 minutes of the movie? No, you're buying a whole ticket. You're watching the whole movie. Even if you walk out early, you bought the whole movie ticket. So let's list this out. We're not just going to say n goes from 0 to 14 because we're dealing with whole numbers here, not all numbers, not fractions. This is a lot like question 1, I think it was. All right, let's make a list. The domain, we're either going to watch 1 movie, 2 movies, 3 movies, 4 movies. We could write it out. We could list it out, 1 to 15. Or we could also write whole numbers, no fractions, whole numbers. From 1 to 15 movies. Okay, and now what about C? What costs are we going to pay? Because normally when we've learned about range in the past, we're just focused on the fact that it goes up and down. This range goes all the possible outputs, all these costs we could pay. This total cost we're going to end up with. Range goes up and down. It's the outputs that make sense for this. Now, the thing is, we're not going to say all numbers from 0 to 40 because you're either paying $8, you're paying 16, you're paying 24, you're paying 32, or you're paying 40. A super fancy way to say this, not super fancy, but if you want to be fancy, you could say multiples of 8 from 0 to 40. Because technically we do have this point right here. I'm not going to, don't sweat that. If you don't put that on there, you're not going to lose any points if you don't mark 0, 0 on the graph. But let's list these out. We might pay, let's just make a list. There's not that many of them. We don't have to list 1 through 15 here. There's only like 1, 2, 3, 4, 5, maybe like 6 prices we got to pay here. So range, I wrote range in green. Let's just make a list. We might pay $0. We might pay $8 if we just watch 1 movie. We might pay 16 if we watch 2, 24 if we watch 3 movies, 32 if we watch 4, or if we watch anywhere from 5 until 15, they're all $40. And that's all the outputs that we could have. That's going to be our range right here. So here's our range down here in green. Now, the whole thing about the piecewise function, it doesn't look like the normal piecewise function we graphed previously up here with the little steps on the staircase. But technically it is 2 functions. Listen, you do not have to write this on the test. If you wrote this on the test, I would give you extra credit points. But what we got here is from, if n goes from 0 up to 5, or technically 0 up to 4, you're going to pay 8 times the number of movies. And then from 5 on up to 5 up to 15, it's just going to be $40. And that's why it's a piecewise function. There's two pieces to this, right? There's the piece right here where we're paying $8 a movie, and then there's this piece right here. We just paid $40 for anywhere from 5 to 15. So technically, this is a piecewise function. Don't sweat that part too much. Like I said, I don't expect you to write out this formula. If you put this on your test, I'd guarantee I'll give you an extra point for that. But you don't have to. Don't sweat it. Don't stress out about that. Just remember your domain and your range. And when you plot your points, think about a real life situation. Don't be intimidated by this graph.